So today we take on to a new topic called dimensional analysis. Dimensional analysis. This particular topic is useful in many branches of engineering, including civil engineering and specifically fluid engineering. So uh, let me give you a little introduction about it. When we don't know a phenomena, we don't know the science of the phenomena, but we know the results. There are certain inputs and certain outputs, but exactly what the science is we don't know. So what do, we do some experimentation. So supposing there are so many parameters involved in the relationship, so we have to perform the experiments very categorically, systematically. So what we do in dimension analysis is we arrange the parameters in non-dimensional groups, and then we do the experimentation systematically by studying a effect of one group on another, while the rest of the groups may be kept constant. So we generate a lot of curves, and these curves could be digitized, also can be given some equation form, and then without ever knowing the science behind it, these results, these curves could be put to some very useful engineering applications. Okay, so we move on to immediately in doing the exercise on rearranging these parameters into non-dimensional groups. Okay, the problem is there is a numerical problem. The resistance force F of a plane, the resistance force F of a plane during flight can be considered as dependent upon the length of the aircraft L, velocity V, air viscosity mu, okay, air density rho, and bulk modulus of air K, and bulk modulus K. Express the functional relationship, express the functional relationship between these variables. Okay, using dimensional analysis. Explain the physical meaning of the group. Explain the groups. Okay, so let me give you what it is. The resistance force of a plane during flight can be considered as dependent upon the length of the aircraft. So F is a function of what? Length L, length of the aircraft, velocity of the aircraft, air viscosity, density, and K. Okay, so actually L will represent all the dimensions. So if it is if it is an aircraft of some proportion, then one of the proportion could be length. So length would represent width also, depth also, the shape also, and so this is about the geometry of the aircraft. V would represent the flow parameter. Okay, V is the velocity of the aircraft, and mu, rho, K, they refer to the fluid in which the aircraft is moving. And F is the total force exerted on the aircraft, because we need to know this, because we want to know the capacity, horsepower or wattage required of the aircraft engine to keep it moving at a velocity of v meter per second. So we have to do the experimentation in the laboratory systematically. So we cannot actually find out the effect of individual terms on F, but instead we make groups, and group versus group experimentation is done. That is easier. So how to convert, how many number of parameters are there? So let me give you. M is equal to 1, 2, 3, 4, 5, 6. 6 parameters. So M refers to number of parameters involved in the relationship. That includes dependent variables and independent variables both. And N is number of dimensions. Number of dimensions involved. Okay. So in the whole uh, equation, how many dimensions are there? Cumulative. This is cumulative. Okay. So what has dimension force has got? Force, as you know, the dimension has got m by ml upon t square. Why? Mass into acceleration. So m is represented, mass is represented by m, and distance per second square, L by t square, is the acceleration. So ml upon t square is the dimension of force. And now L, length of the aircraft, has the dimension L, fundamental dimension. And what about V? V has the dimension of L upon T. Mu, mu has the dimension what? M by LT, kg per meter per second. And rho, mass density. So rho is mass per unit volume. So M, volume means L cube. And K, K is the bulk modulus of elasticity, that is defined at pressure upon volumetric strain. So volumetric strain is actually dimensionless, strain is dimensionless. So it has the dimension of pressure. Pressure means force upon area. So you know this, force ml by t square into 1 by L square. This is dimension of K, force upon area. So K has the dimension of m by LT square. Okay. So how many dimensions are involved in this relationship? Here it has MLT, L, L by T, M by LT, M by L cube, ML by T square. So everywhere you get either M, L or T, all the three are involved. So N will be equal to 3. So number of groups that could be actually formed is given by what is called a Buckingham Pi Theorem. So let me give you what is Buckingham Pi Theorem. Buckingham pi. This is pi theorem. It says that if it is so, the number of parameters are m, number of dimensions involved in the all the parameters is n, then number of pi terms would be equal to, they are also called non-dimensional group, will be equal to m minus n. That is 6 minus 3 equal to 3. Okay, so let me work out. Now, while deriving these groups, we use the phenomena of what? The dimensional homogeneity of the equation. We have already we have seen that there is an equation, then on the left hand side, whatever be the dimension, say if it is meter per second, so all other terms on the right hand side should be in meter per second. So dimensions are same. Okay, let's say area is equal to length into width. So on the left side, area means L square, and on the right side there is length into width, that means L into L, that is L square once again. Okay, so this is called the principle of homogeneity of dimensions of an equation. So we make use of this. So Buckingham Pi Theorem has said that there would be 3 pi terms. Let me call them pi 1, pi 2 and pi 3 terms. So pi 1 term would be equal to what? You have to actually choose repeating variables. So repeating variables would be from amongst these parameters such that there would be m repeating variables. That means 3 repeating variables are to be chosen out of 6, such that these 3 have all the dimensions. That means m, l and t, all the 3 dimensions are possessed by them, but not individually but collectively. So let's say, for example, we take L, and we take, let's say, rho, and let's say V. These are the repeating variables. So this will have dimension L, this will have dimension m by L cube, and this will have the dimension of L by t square. So look at this. It has got m also, L also, and t also. Okay. So together they do not form a non-dimensional group. Whatever division, multiplication you do with these 3 terms, they will not vanish. So something will remain. So non-dimensional group formation is not possible with these 3 repeating variables. That has to be considered. That has to be kept in mind. So pi 1 would be equal to repeating variables L raised to some unknown power multiplied by second repeating variables rho raised to power some unknown power, and V unknown power C multiplied by some one of the terms. So how many terms are there? Rho, L, V, F, mu and K. So rho, L, V you have already taken. So you have to take them one by one. So let's say F. F raised to some unknown power. Similarly, pi 2 will be L raised to unknown power rho V, and then you have to take what, mu here, and pi 3 would be L rho V raised to some unknown power, and then k. Remember that this f, mu and rho is not raised to any power, but only the repeating variables are raised to some power. So let me work out a non-dimensional group arising out of rho, L, V and F. Okay, so this is pi 3. Let me do it. So pi 3 is a non-dimensional, pi 1 or pi 2 or pi 3, they are non-dimensional group. That means they have got no dimension. So pi 1 could be replaced by m0 into L0 into T0. Okay, m0 is 1, L0 is 1 and T0 is 1. So 1 into 1 into 1 is equal to 1. This is a number. So that is equal to L. What is that L? L has got the dimension L raised to power A. This is m by L cube raised to the power B. This is L by T raised to the power C. And F is ml upon T square. So this is fourth dimension. Now look at this. Left hand side has got MLT terms and right hand side also has got MLT terms. You can rearrange the right hand side. Let me do it. M0 L0 T0 equal to, take L to the power, this is because they have multiplication terms in between. So A minus 3B here plus C plus 1. Look at this. L raised to the power A. This is L raised to power L into minus 3B. This is L to the power C. And this is L raised to power 1. So this is it. L and M. This is B plus 1. Here B plus 1. And what about T? T here you don't have T, so this is minus C minus 2. Okay. So this is m raised to power 0, L raised to power 0, T raised to power 0. Here L raised to power something into m raised to power something, T raised to power. So look at this, the bases are same and the powers are different. So you can equate the powers. So m raised to power 0, so 0 equal to b plus 1. L, that is 0 equal to a minus 3b plus c plus 1. And here t, that is 0 equal to minus c minus 2. So you can work out a, b and c. Okay, this is m raised to b plus 1, I'm sorry, b plus 1. And this is L is, okay, this. Okay, so b equal to minus 1, c equal to what? Minus 2, and a equal to, when you substitute a and b in this, you will get a equal to, so b equal to minus 2, so this becomes, sorry, minus 1, so this is plus 1, b minus 1 into minus 3, so that is plus 3, plus 1 plus 4, plus 4 minus 2 is equal to plus 2. So a equal to minus 2. So substitute here in this relationship. So pi 1 will be equal to L raised to the power a, that is minus 2, rho raised to the power b, b is minus 1, and v raised to the power what? C, c is minus 2, and f. So you can write f upon rho L square b square, rho L square. So this is your pi terms. So if you work out the dimension of f upon rho L square v square, you will get no dimension. Okay. Similarly, you can work out pi 2 term. Okay, so let me do the exercise for finding out pi 2 terms. This is m0 l0 t0 equal to, what is that, rho l square, rho raised to power, what is that, l raised to power a, sorry, l raised to power a, rho raised to power b, p raised to power c, and for pi 2 we have taken mu. Okay, so this is mu. Okay, so let me work out the dimension. L raised to power a, this is m by l cube raised to power b, this is l by t raised to power c. Okay, and mu is m upon lt. This is 1. Mu is m by lt. Okay, fine. So this is m0 l0 t0. Now you can write down the powers. 0 m for m, 0 equal to, this is b here, plus b plus 1. For l you can write 0 equal to a minus 3b minus, plus c minus 1. A minus 3b plus c minus 1. And here 0 equal to t raised power 0. So consider all the t terms. So it will be minus c minus 1. Okay. So from here you get b equal to minus 1, c equal to minus 1, and a equal to, this is plus 3 minus 1 minus 1. So a equal to minus 1. Okay. Look at this. A equal to minus 1 plus 3, so minus 2, minus 2, no, b equal to minus 1, c equal to minus 1. So this will goes, this cancels, and b equal to minus, so plus 3, a equal to minus 3. Okay, so minus 3 plus 3, this cancels, minus 1, minus 1, c is minus 1, this is minus 3, plus 3, minus c plus it cancels, c equal to minus 1, minus 1, minus 1, minus 2, no. So b is minus 1, c is minus 1, a is minus 1. So it could be written like this: pi 2 equal to L to the power minus 1, rho to the power minus 1, v to the power minus 1, and mu. So this is mu upon rho L v. This is your pi 2 terms. Okay. Similarly, you can work out the pi 3 term. Okay. So this pi 3 terms comes out to be, by the similar process, k upon rho v square. Okay. So you can write down the relationship like this: pi 1 is equal to a function of pi 2 and pi 3. Or you can write, what is pi 1? Pi 1 is f upon rho L square, f upon rho L square V square is equal to function of pi 2, that is mu upon rho LV, and this is k upon rho V square. Okay, so I told you this helps in doing the experimental work. So earlier we had 6 parameters, so it was difficult to perform experiment with one independent variable and 5 independent variables. In all there were 6. Now you have only 2. So this is dependent, this f is the dependent variable and this is the function we have worked out. So this group f upon rho L square V square will be studied with reference to pi 2 and pi 3. So how to do it? Pi 3 will be kept constant and you have to draw a curve between pi 1 and pi 2. Okay, you will get set of curves for various values of pi 2 and various values of pi 1. You get set of curves and one curve for one value of pi 3, another curve for second value of pi 3, another curve for third value, and so on. Similarly, while studying the variation between pi 1 and pi 3, you will keep pi 2 as constant. Okay, so you will get one curve for pi 1 versus pi 3, while you will keep some value of pi 2 equal to constant. Another curve between pi 1 and pi 3 for another value of pi 2, and so on. So I'll show you how. So this is my pi 1 and this is my pi 3. Let's say I am getting these curves. This is for pi 2 equal to C1, pi 2 equal to some other value C2, pi 2 equal to some other value C3. Similarly, I'll get curves for pi 1 versus pi 2, while pi 3 is kept constant. Let's say this is C1 prime, pi 3 equal to C2 prime, and this is pi 3 equal to C3 prime. So with the help of these curves, we can actually draw many engineering calculations and do the design without ever knowing the science behind the aerodynamics of the aeroplane. Okay, so that's how we have to do the in this exercise of converting number of variables into non-dimensional groups or called pytrons. Okay, now the representation could be like this. Pi 1 could be replaced by another pi 1 into pi 2, or it could be replaced by pi 1 by pi 3, but you have to, this should have pi 1, or pi 1 could be raised to some power, okay, say minus 3 by 2, any fraction or minus etc. it could be raised, okay, or pi 1 could be multiplied by some arbitrary constant, let's say 5 pi 1. So this is required sometimes to bring the non-dimensional groups in some desired format. Okay, so this exercise we'll see later.